Hey, algebra guys, I just want you to know that I'm going to work on these solving inequalities. You guys are getting so good at solving equations and solving inequalities, and I wanted to push past the absolute value equations first and solve inequalities, and we'll catch more absolute value stuff on the compound side of inequalities. Let's just talk about this. We're following the same steps that we usually follow, but we're talking about inequalities. And there's only one minor exception to the rule when we solve inequalities, and we'll get to that later on. There are no examples of that here. I'm going to show you a what if, and then you'll be able to graph it. The only thing about inequalities is once you're finished solving an inequality, and I don't like the way they do that, and they skip steps in there, it's the graphing piece that we'll talk about later on. I'll show you what they do here, and then I'll show you what I'd like to see you do, and what most of you have already done on a regular basis in my class. So we have this inequality here, and I guess I didn't show you the original problem. If I could find it and just scoot up just a little bit. There it is. There's our example problem. It's 2x plus 4 is greater than 36. That's how you read it. That's what it looks like. I want to treat this inequality symbol pretty much like I treat an equal sign when we solve. And you write it out, and I know they like horizontal math here. Like I said, I despise horizontal math because when you get to higher level thinking, if you're talking about physics, you're talking about chemistry, and you're solving equations, when you get to calculus, there's no way on God's green earth that they like horizontal math. We like everything vertical. Everything comes down the lane, and then when we need to shift and start a new column, we start a new column. That's how it works in mathematics. So I'm gonna write this with horizontal math out of the equation. I just want to rewrite this, and then I want to perform the functions that they did. What they did was they subtracted 4 from both sides, and they showed it their way, but I like to show it my way. Minus 4 on both sides, and then we get to 2x is greater than 32, and we get to the same spot. We're at the same spot, and we understand that yes, we divide both sides by 2 and we come up with 16, but we didn't show it, so Sokol makes you rewrite. If you don't rewrite, that's okay. You just perform the task on it. That's okay with me too, if you just write it right here. But you know what? You come up with the same answer, and you still come up with x is greater than 16, and that's okay. Now, when we start to graph, if your inequality symbol is greater than or less than, and does not have the equal sign, well, if it doesn't have the equal sign, then we assume that this actual number 16 is not a solution to this problem, because we're looking for a number times 2 plus 4 that is greater than 36. Well, if we plug our 16 in, we get 32 plus 4, which is 36, but that isn't greater than 36. So we put an open circle around the 16. That means it doesn't include that value, and then we shade everything to the right and tack an arrow on it, and we're good to go. That's everything is greater than 16. This is really cool. This is set builder notation. You'll get used to this. If you don't know it, this is x is the set of numbers greater than 16, and then later on we're going to build on top of it to make x an element of real numbers, but that's later on in our course. I'm going to move over here because this actually does have our our one exception to the rule of just doing the math and bringing our inequality symbol down. So I'm going to erase this to get it out of our way because I'm going to write in that space there. This is 17 minus 3w is greater than or equal to 35. And I'm going to rewrite it up here. 17 minus 3w is greater than or equal to and equal to or equal to 35. All right, well, the first thing I have to do is step one, undo any addition or subtraction. And this is what's being tacked on. This whole number is being tacked on. So I have a positive 17. How do I undo that? I show minus 17 or negative 17, and I get rid of it. Well, I put minus 17 there, and then I bring down my negative 3w. I keep the operation symbol as a negative. I show greater than or equal to, and then 35 minus 17 is actually 18. And I've gotten here just like we did, just like they did, all right? And what they did was they just showed both sides being divided by a negative. And they didn't make a big deal about what happened here. So the idea is if you multiply or divide by a negative across an inequality symbol, you have to reverse the inequality symbol. And I'll show you why that works when we plug this back in to check and see if the answer is correct. And so I'm going to rewrite this here. Minus negative 3w divided by negative 3 is greater than or equal to 18. Now that I've divided both sides by negative 3, I turn the inequality symbol around. I flip my inequality symbol around, and I say that w is less than or equal to negative 6. Now, what if I'd left it alone, right? I'm looking for numbers that are greater than 35, all right? So, what if I just left it alone? And let's find a number that's greater than negative 6, just for fun. A number that's greater than negative 6, let's put in a 1. 1 is definitely greater than negative 6. So if I put a 1 here, and I do the math, 17 minus 3 times 1 is 3, right? So if I didn't move the inequality symbol and left it alone, I would be wrong. Because 17 minus 3 is not greater than or equal to 35. So, the only way to make this work is to flip the inequality symbol. It's the only way. When we multiply by a negative, we have to flip it, and it makes it work. So now let's look at something that's less than negative 6. Let's talk about negative 7. If I put in a negative 7 up here, I have 17 minus, well, that would be negative 21, minus a negative 21, 17 minus negative 21, minus a negative is like plus a positive, and that gives me 38. Is 38 greater than 35? Yes, it is. So we know that we're on the right track if we do this. Those are the only big problems when we're working with this. We got to our solution. W is less than or equal to negative 6. Because it includes the equal sign, we put a closed circle on negative 6 because negative 6 is also a solution to this. Negative 6 gives us that 35, right? And then we shade everything to the left of it because everything to the left of it is negative. All right, I want to do one more example problem because I want to show you what you have to do to these problems beforehand. I would, if I had to, let's go ahead and really blow this up so I can give myself some space to work. I'm going to give myself some space to work on number 2. Number 2, it's not that exciting. Let's go ahead. Yeah, let's do number 2. Why not? All right. So I have the inequality of 3 times the quantity 9z plus 4 is greater than 35z's minus 4. Oh my gosh. Oh my gosh. What do I do first? Well, step 1 says undo any addition or subtraction. But my pre-step says get rid of any fractions or distribute. So our pre-step has to be this distribution here. We have to multiply both things inside these parentheses by 3. And so when I do, 3 times 9z is 27z, plus 3 times 4 is 12. I'm going to shift this over because I was running into something over here. Is equal to 35z minus 4. Okay, well, I've seen students do both pieces of work at the same time. I really personally like to have a positive variable value that I can work with. If you want to, you can, whatever. Let's get rid of this addition or subtraction. And I'm going to solve for my z on the right. I'm going to add 4 to both sides. Could we have subtracted 12 and then, yeah, we absolutely could. But I'm going to add 4 to both sides. And what I come up with is minus 4 plus 4 is 0. 12 plus 4 is 16 plus 27z's is greater than 35z. Good? All right. Well, now I'm going to go ahead and subtract 27z from both sides. Uh, 35 minus 27, did you guys know that that happens to be 8z is less than 16? Hey, look at that, it works out pretty well. Sokol likes to rewrite and then do the math on underneath it. It's a little bit cleaner, it shows where I've arrived. It shows the next operation. That becomes a 1, and 16 divided by 8 is 2. So let's see if that anything less than 2 is a solution. Okay? And that's what we want to find out. This says that anything less than 2 is a solution. Well, I like to try this with 0 because that's less than 2 and I don't have to do any heavy lifting. All right, so even if I distribute, even if I decide to go ahead and do this, 27, I don't feel like it today. All right, I'm going to just be lazy and I'm going to go ahead before anything starts, put my 0 in. All right, 9 times 0 is 0 plus 4 times 3. 3 times 4 is 12. Is 12 greater? 35 times 0 is 0 minus 4, which gives me negative 4. Is 12 greater than negative 4? You bet your life it is. It is a solution. We've done everything correctly. There we go. And I've checked it. And that's basically the big idea with our inequalities. I'm going to move to the other page after I erase because it's going to be hard to see. Pardon me while I erase. I know I'm holding you up. I'm sure you have lots and lots of wonderful things that you need to be doing right now. Here we go. Now they're going to give us something that's annoying. Where is it? It's not this one. This one is the same. This is the same idea. You distribute first and then do the math. I believe, if I'm not mistaken, it's this ugly guy over here. Oh my gosh! What do I do? There's a quantity over a denominator of 3, so that's division. Oh my gosh, I can't undo my addition until I've taken care of this fraction here. Oh my gosh. All right, we're done, right? So I apologize for acting like a fool, but here's my original inequality, greater than or equal to the quantity c plus 4, and this is a quantity unto itself. You can put it in parentheses just so that you remember it's a quantity unto itself. I want to get rid of this, so what I'm going to do is I'm going to take my green marker, because that shows up, and I'm going to multiply the whole thing by 3, because it's being divided by 3. So I'm going to multiply both sides by 3. And the best part about this is I'm so close to being finished once I do this multiplication. Divide by 3, multiply by 3, they are opposites, so they cancel each other out. So on this side I have c plus 4 is less than or equal to 3 times c is 3c. Okay, well, this is kind of cool. I have 3 c's over here and 1 c over here, so why don't I take my 1 c and get rid of it on this side by subtracting 1 c minus one of those c's, and I have 2c is greater than or equal to 4. I could leave the plus sign in there, that's okay. I would rewrite, I'm going to shift way down here and rewrite it. 2c is greater than or equal to 4. I'm going to do my division underneath it, and looky there, c is greater than or equal to 2. So there are some things you have to take care of first. Pre-work for our two-step equations is get rid of any fraction if you can, do some distribution like this one if you have to. Other than that, I think you guys have a very good handle on this. Of course, as always, any questions, please, please, please go ahead and send them to me via Google Classroom, or catch me in class, send me an email, any old thing like that, and we'll be good. We'll be good to go. Thanks so much for your time, and this is Solving Inequalities, and I believe, if I'm not mistaken, Solving Inequalities is section 1.5 in your text, and you should be able to finish up. Thanks.